Good morning, people. Good morning, Bhushan, Ashutosh, Aditya. This is Durvesh, Kirti, Ishwari. Good morning, Achal, Yuga. And this is Purnima, Swarada, Ajit, Manjiri, Maitri, Gorab, Anjali, Prajwal, Suharsh, Bini, Tejas. All of y'all, a very good morning. Interestingly, you'll see that the setup has changed completely for the day. The reason being that I have an official function in the college. I've arrived in the college and I'm conducting my session, today's session from here. Dinesh, good morning. Saket, good morning. Okay. Not much is going to change, only the backdrop has changed. And in fact, speed-wise, the other day somebody was saying that, Sir, Naya, अच्छा वाला internet ले लो. College has a very good internet. I checked it. It's 30 Mbps. So it's quite a speed, I would say. As far as college bulletin is concerned, not much to be shared with you all. But yesterday, we were into revising all that we were doing, rather have done. And today we should be continuing with that. Let us immediately go into that, basically, because now we need to move a bit faster. And here is where I would be starting for the day. Now, I would have a bit of problems into looking into these things because there is a lot of light around me. I have spoken in detail about physical geography. I'm not very sure whether I've spoken about human geography. Whatever the case, I will just brush it through today. As far as your syllabus is concerned, well, this is the whole spectrum of human geography. As far as your syllabus is concerned, you would be having some parts of it. Say, for example, population geography, the distribution of population in India, in the world, some parts of Maharashtra. An interesting development that has happened with your syllabus is that keeping in mind the civil services examination of the state as such, we have introduced geography of Maharashtra as well. And that would not be this year, however. It is going to be next year. As a first semester, SYBSc is going to be geography of Maharashtra physical. And the second one, that's the second semester in SYBSc, is going to be geography of Maharashtra human. As far as these other aspects are concerned, population geography includes, so to say, the census and how population grows and so on and so forth. Cultural geography is not a part of your syllabus, but then settlement geography is a part. You'll see that human settlements normally settle down in two major distinctions: rural settlements and urban settlements. They have their own geography as far as their settlement is concerned. So settlement geography is something that we are going to do. Political geography is something that you don't have as a part of your syllabus as such. But then as far as the rest of your syllabus is concerned, it would be including a significant part of economic geography. If you remember, economic geography is man-made geography using, say, man-made commodities or let us say natural commodities, and they provide us with various resources. This could be food resources and others. Okay, we are going to do food resources. Agriculture is something that we are having, and Tigre sir will go into the details of that. We have industrial geography, we have transport geography. Resource geography is a separate topic in itself. So is geography of development. So you would not be having that with you all. So that is as far as once again a broad discussion of the classification of geography as such. And yes, yesterday we spoke about scaling of maps. Okay, the more you detail you go into a particular area, the larger details, I would say, that is how you would remember it. The larger the details, the larger the scale, and the lesser the details, lesser the scale. Now, when I say larger details, it is with human aspect. Okay, you'll see that as far as the first map is concerned, that also has a very large detail, but you are not able to observe all this with human eye. Okay, what you are going to observe is at say this fourth diagram. So this is going to be large scale, this is going to be small scale, and of course these are intermediate scales. Let me tell you, scale is going to be relative. Okay, when if I have the whole world map, then this map is going to be larger in scale as compared to the whole world's map as such. So keep that in mind. That's very important, that you have to keep in mind. These are relative maps. Yes, you're going to have smaller maps, but when you are comparing two maps, okay, the one which shows larger details of the world is small scale, and within that, say larger details of land is going to be large scale. So that is a bit confusing at times, but once you get the logic, it's going to be significantly easier as such. And then we went into these various perspectives in geography. What is the viewpoint? Is nothing but the themes of geography: place, space, and scale. What synthesis does geography go into? It has its physical subfields, it has its human subfields, and of course it has its borderlines, that's human physical interactions as well. What does geography represent? It recognizes things. Okay, so you'll see that when I see a mountain for the first time, I will say retain it in my mind, and when I see another mountain at some other time, I will recognize him. So cognitive skills are very important, because geography primarily has been an informative type of uh, uh, subject. Okay, and then we spoke about modeling, of various types of modeling, transport modeling in human geography, to say modeling of climate change, that's in physical geography. Either cases, we tend to use mathematical and statistical models as such. When we see something, we tend to describe it also. We tend to describe the process also. So that is descriptions which come up in representations in geography as well. And then we have visual displays also, diagrams, tables, etc. And of course, all this in a digitized format comes when we have of late, last 2 decades or so, we have introduced what is called as GIS, Geographic Information Systems. This is what we stopped at, I suppose, yesterday. And continuing with the app, those who have downloaded the app, it's fine. But those who don't have this app as such, I would still request you all to bring in this app as one of the major apps in your Android phones as such. I have gone into further details as such. You'll see that in that map, in that app, once you open the app and you have your local area, you'll see that when you scroll down, you're going to have there are a few disturbances here and there, but they should not be a part of our lecture. So you have a weather map, and you'll see that in that weather map, I can see a few places. The southernmost, you have Ratnagiri, Sangli in Maharashtra, and then you have Pune. And because I clicked it when I was at my residence, you'll see that I am placed a bit northwest of Pune then. And what's interesting is you can see that Pune is going to be sunny, and there are going to be some areas where you're going to have some clouds. So this is very interesting. And as far as the left side of that particular screenshot is concerned, you'll see that I can see what happened in my place or around my place 24 hours ago, what is happening right now, what is going to happen for the day, what will happen tomorrow, what will happen day after tomorrow, and after the day, and of course the day after that. So it's very, very predictive as such. So it's very interesting. And in fact, you can play the simulation if you just click the play button at the base as such. So all this is available. Not only this, you'll see that you can zoom in or you can zoom out. Okay, you can go further into or nearer to the place you are, or you can see scales to the scale of Maharashtra, or if you want to see India, and in fact you can zoom out to see what is happening in Asia and around as well. So a fantastic thing to have as a student of geography is concerned. And then further down, you'll see that this is a forecast in a pictorial format, I would say. What is the daily forecast? This is very similar to what we have seen yesterday also. and you have throughout the day it's going to be a bit hazy and so on and so forth. Then coming to another screenshot, you further scroll down. What is interesting is that you can have a 15-day weather condition, 14-day weather condition, should we say. Today is Tuesday. You'll see that the higher temperatures or the max temperatures are not going to vary much. You'll see that from say around 31 today, the next 4 days it's going to be 31. Then the next 4 5 days it's going to just drop by 1 degree, and then it's going to again rise. Say next Monday, it would be rising to 32. Now, what is going to change up? Because we are in a winter, you'll see that the minimum temperatures are going to change much. Okay, the minimum temperatures for the day uh, reported here are 20, and they are seen to be dropping down significantly by next Tuesday. Okay, we are going to have the coldest day of this span of 14 days. Let me tell you. Okay, it's going to be 13 degrees minimum. After which again it's seen to be rising, and say at the end of the next Monday we would again be at 20. So today and that Monday is 20, and in between you're going to have a cooler patch as such. So it's all these things that we can utilize. Now another thing is, when I am looking at these things, I can share this on Insta, I can share this on Twitter, and I can share this on my Facebook profile as well. Okay, you can do it here as well as here. These three dots you can see, you just click there, and you tend to have an option to share that particular content as such. So it's very interesting, and as you learn to read these, you'll see that you understand more and more of geography as well. Okay, so this is the information for the day, new information for the day. And let's move. Yesterday, yes, I remember we stopped at geography and the dichotomies that we have in geography. Dichotomy in the sense that some geographers think of geography in one particular way, some geographers feel geography in other particular way, and as a consequence you have two, I would say, phases of opinion as far as geographers are concerned. How the thing is that of late these things are changing, but there have been times, I think I did say about this yesterday also, that there have been times that geographers have been dead against each other because of these dichotomy. Now, what are these dichotomies? The first dichotomy is physical versus human. Okay, or it's also called as natural versus political dichotomy. Now, what is physical versus human? Now, you'll see that geography basically is divided into two major divisions: the natural part of the earth and the say the human induced part of the earth, and that is why we call it as physical geography, and we call it as human geography as such. Now, what happened over the period of time because of human ego, and I would say underliningly say here that this is one thing that human beings, if they keep it at bay, you'll see that it's going to be helpful for the success of that particular individual. What's that? Ego. Because you'll see that this dichotomy emerged because of ego. What happened is that some people were more interested, one, some geographers I would say, were more interested in physical geography, while there were other groups, and I'll not go into the names of that because that's a separate section of geographical thought. They were more interested in human geography as such. Over the period of time, say in the battle of intellectual superiority, what happened is physical geographers started looking down upon human geographers, and human geographers started looking down upon physical geographers, and their ego kept them at each other at bay. However, let me tell you, as students of geographer, we need to look at geography from one point of view. Then your question would be, sir, how is it that they went into debating into each other as far as physical and human geography is concerned? That basically happens when you have a parent subject as huge as geography. You'll see that though geography seems to be easy, yes, it is easy because you see geography all around you. But the scope of geography, the panorama of topics that geography encompasses is huge. And as a consequence, what happens is you tend to get stuck with one particular thing because you appreciate it well. I like physical geography, so I go into the details of physical geography. I may not have that much of time to go into the details of human geography as such. As a consequence, over the period of time, when somebody asks me about, say, for example, this is just a hypothetical condition, but normally it does happen with an individual, that somebody asks questions on human geography to a physical geographer, and probably he doesn't know the answer. Now, this scholar would be stuck up and say, and how would he admit that, sorry, I don't know this? So, what does he say? Start saying that, well, I can tell you physical geography, human geography is not that important. It starts at such a subtle note to an extent that they just, as I said, they just start looking down into each other. Okay, physical geographers say that human geography is nothing. The best part of geography is physical geography, and human geographers would say physical geography is zero without human beings. Okay, and they have their own arguments, and they would be looking down on physical geography. So the battle, intellectual battle, intensifies. Of late, however, because most of the subjects, including geography, are going interdisciplinary, you'll see that this has been coming down, but there still tends to be this feeling of separation into physical geography and isolation into human geography. So this is a major dichotomy. Then you have a dichotomy between the process as to how you learn geography, whether you are learning it in a systematic way, whether you are learning in a regional way. Now, what does systematic basically mean? Okay, you'll see that a system is basically a set of arranged steps as far as what happens after that. Say, for example, when you are taking admission in FYBSc, there is a system, isn't it? The college will first advertise, then say you have to visit the site, you have to fill the merit form, then you fill the say admission form, then you fill the fees, and of course then you join the groups. You'll see that there is a sequence that is followed, and this sequence, when followed systematically, this is supposed to be a systematic approach. Regional is something wherein you take everything. You are looking at SP College, and you are looking at the admissions of SP College, the academics of SP College, everything. Now, putting this in a geographical sense would mean that when I'm speaking about systematic geography, I take a particular system. Say, for example, it could be natural, it could be human. I take a system like a river systems, and I would study only the rivers in different parts of the world, or possibly in India, or possibly only Maharashtra, given my scope as such. Okay, so I have identified a system, and I'm going after that. I could be doing mountain systems also, fold mountains, volcanic mountains, and other mountains as such. All these mountains, mountain is a system in itself. Mountain building is a system in itself. So if I'm doing only mountains, I'm going to go systematic. As far as let us say the transport systems are concerned, within transport systems, I would be studying the railway systems. Now, certainly I've just shifted to human geography as such. I could be doing the railway systems, I could be doing the road systems, the highway, etc. So if I'm taking one, say, in other words, what I'm doing is I'm specializing in one particular thing. That's called being systematic. What is regional? Regional, you have been doing what is regional. You'll see that in ninth standard, 10th standard, when you did Maharashtra, I'm referring to different boards. When you did India, okay, you took India as a region. You remember the themes of geography? You took India as a region, and you studied all systems within India. You started with the physical system, physiography, then you went into the climate system, climate of India. Then we spoke about the drainage system, the various rivers. So you'll see that while a systematic study is doing only rivers, regional geography has identified a region for itself, and it is going to do multiple things within that. Okay, so all the links into physical geography, from you could be doing the soil, and you could be doing the natural vegetation, and you could be doing the natural animal life, wildlife also in that. Similarly, you go into human, you do agriculture of India, you do industry of India, you do population of India. The region remains common, but you will see that you pick up all other aspects of geography for that particular region. Some geographers went the systematic way, some geographers like the regional way. So it tends to be very difficult to say. Of course, none of them is superior to each other. It's just looking at this. Okay, somebody could be reading a hand like this, somebody could be reading a hand like this. I would say systematic versus regional is just like this hand, this side of the hand, or this side of the hand. Okay, but as I said, at times it tends to be debatable, and then you go into these dichotomies. Another popular dichotomy that you find in geography is determinism versus possibilism. This philosophy is used in various subjects as well, but as far as geography is concerned, I would say a deterministic approach in geography basically includes, or rather says and speaks about the fact that it is nature which is dominant and controls whatever activities are around us. On the other hand, the possibilistic view, the geographers following a possibilistic style would say that wherever possible, human beings have brought about the change. Now, both of these are true. Let me tell you, both of these are true. The problem comes when one of them says, this is the only absolute truth, or the other one says that no, this is the only absolute truth. We have to remember that both of them, yes, nature is also important, and possibilistic basically means wherever possible, human beings have been able to change these things. And say a simple example is, unlike other animals in the world, say for example an elephant, an hippopotamus, a polar bear, whales in the sea, lions, tigers, you'll see that they have their specific type of climatic region. Unlike that, you'll see that human beings tend to live all the way from the equatorial type of climate all the way into the tundra region also. This adaptation has been possible because of technology, and that is why the possibilistic view also stands. But you'll see that while we say this, okay, the present things around us, we are not able to move so freely, basically because of this attack of corona around. And here again, we eventually come to believe that yes, nature tends to control things when they tend to get out of hand as such. So we what I would suggest you all is, we have to have a balanced view on these two. Okay, we should not fall like lopsidedly into any one of these dichotomies. We are students of geography. Geography includes all of them. Okay, and in fact, at the end of the day, we should be modest. Okay, it may so happen that I may like physical only, or I may like human geography only. Then I should not be egoistic. I should be modest enough to say that, well, I know that the geography, the mother of all sciences, is a huge scope, but I like this particular part. I like a systematic approach. I believe in deterministic view. Okay, we should not say that the view I am maintaining is basically the ultimate, or the superior view. I would rather put it that way. So that is as far as the dichotomies in geography is concerned. It's very important to uh, think about that as such. Okay, so we'll move ahead and go to the next. Now, this is a very interesting photograph that I have put up here. With the BA students, I did it much ahead of time, but for us it took some time. Now, what do we want to see in this particular diagram? You'll see that what should a geographer actually see in this particular diagram? You'll see that you have the sun, and you have the comparative sizes of the various planets. You'll see that even the largest of the planets here, Jupiter, which is to the extreme left, is so small as compared to the sun. Okay, and then you come to the next of them, you have Saturn, and then you have Neptune and Uranus, and of course then you have the Earth, and then you have, of course, the smaller planets, Mercury, Mars, and Venus. And of course you have the smallest one, which is Pluto. Of course, there is a debate whether we should be calling Pluto as a planet or not. Some scientists call it as a dwarf, or a dwarf planet, and so on and so forth. What I want to tell you all is, uh, this is something that we have to keep in mind, because if you remember the various diagrams in say involving the earth and the sun in your geography textbooks, they must have been much different, isn't it? Let us see if we can have any similar diagrams. Uh, i was okay, yeah, see, this is one of the diagrams. Okay, we were to come to this later, but this is one of those diagrams. Now, what do you see here? Is the size of the sun and the earth anywhere comparable to the actual sizes we have seen? Okay, the actual size here is sorry, is this, and you'll see that we have come to this particular size, isn't it? And you'll see that why do we have to understand these equations? Now, remember that this there is nothing wrong in this particular diagram, basically because we have to understand conditions on the earth. Now, had we placed the earth to be its actual size as in comparison to the sun, it would have been very difficult to explain the content. And that is why you'll see that normally when we draw these diagrams, you'll see that invariably teachers will show the diagram of the earth to be the size of the earth to be larger than the sun. Okay, it is, as a matter of fact, only done for the purpose, sheer purpose, that you understand what is happening on the earth. We need not understand, we don't have to understand what is happening on the sun. Okay, this is in relation to the earth, and that is why the earth is shown that way. And as a consequence, you'll see that when we speak about these the rays of the sun, they are parallel. You'll see that the left diagram, they come parallel to each other. On In contrast to this, if you remember drawing the sun and its rays in first and second standards, you'll see that you must have drawn it radiating away from the sun, isn't it? And how is it that when the rays of the sun actually radiate from the sun, when they reach the sun, when they reach the earth, sorry, they are parallel to each other. Now that connection is only justifiable when you say that yes, the sun is very, 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 very large as compared to the earth. It is for our own convenience that we show the earth to be significantly large in its position as such. So that is something that we have to keep in mind. Always keep in mind that the sun is very, very large. Unfortunately, it so happens at times that teachers don't get into this particular concept as such. And that is why you'll see that when you go in deeper into the concepts of relationship between the earth and the sun, you'll see that I have seen students getting confused. In fact, there have been students who have asked that, sir, in our younger days, we used to draw radiating energy or rays radiating from the sun. And when you are showing insolation, that's incoming solar radiation, you see that the rays of the sun are parallel. You'll see that you have to go in zooming to such an extent that the two rays of the sun literally seem parallel to each other. They are not parallel, but they seem parallel to each other. That's a very important thing, and that we have to remember. This is a very common misnomer that we tend to have as far as geography is concerned. Then, before going to the further aspects, one slide that I have put here is regarding a point of discussion which is so very regular around us. Okay, nowadays you'll see that at government level, at conference level, at scientific levels, what we speak about is climate change. And as far as climate change is concerned, a very interesting aspect about climate change is say a misnomer, I would rather say, as far as climate change is concerned, is that unfortunately the layman understands the effects of climate change as climate change. In the sense, when I say sea level is rising, when I say polar ice is melting, that's an effect of climate change. It is not a cause of climate change. And there is a difference between an effect of climate change and cause of climate change. As far as the causes of climate change is concerned, yes, we keep on saying that human being or man is responsible as far as this climate change is concerned. And as a consequence, we have these different discussions. However, you'll see that when we speak about climate change, there are some basic natural things which see these changes in climate happening. Now, what were these basic things? Okay, this is something related to the earth itself. This is something related to the earth and the sun. Now, what is this? It was in 1940 that a Yugoslav scientist by the name Milankovic, okay, you can see the name on your screen here, Milankovic, he proposed three basic things happening with the earth itself and the relationship between the earth and the sun, which were called as the Milankovitch cycles. He said that it is these cycles which are responsible for climate change. And you'll see that it is not that the climate change, say, it's progressive, it's cyclic. You'll see that you return back to a particular point after you have gone through a particular process of climate change. And it's climate change actually is a combination of these basic things. If you want to go into the details of that, the right top of your screen, you can see a YouTube link. You can just copy that YouTube link and you can check on YouTube. It shows it explains climate change, the Milankovitch cycles, in a very interesting way. Now, what are these three cycles of Milankovitch, of which Milankovitch had stated? It's the cycle of eccentricity, it's the cycle of obliquity, and it's the cycle of precision. Now, what exactly do these three mean? Okay, we'll come to each of them one by one. Okay, you'll see this is a broader diagram of the three, and you'll see that when we speak about the obliquity, you'll see that the cycle is of around 41,000 years. If we are saying eccentricity, this is somewhere between 1 lakh years to 4 lakh years. And when we speak about precision, this is going to be 26,000 years. Now, these are numbers, but what does this geographically mean? We need to understand it one by one. Let us take them one by one. The first one, let us say, is just let me see if I can animate it. Yeah, you'll see that it is animating now, and you'll see that the axis along which the Earth rotates, the axis along which the Earth rotates is basically tilted presently at an angle of 23.5 degrees. Presently at an angle of 23.5 degrees. But you'll see that it keeps on changing between 21.5 degrees and 24.5 degrees. Okay, now what does this signify? Geographically, this means that when the tilt becomes less, the degrees go lesser, you'll see that the tropical regions will be lesser. That means the Tropic of Cancer and the Tropic of Capricorn will shift nearer to each other. That means you are going to have a colder period. That means you will have an ice age. Probably you'll have a glacial age. But you'll see that when the tilt goes more, okay, it goes towards 24, you'll see that the tropics go away from each other. That means the warmer parts on the surface of this earth will increase, and of course you will have a warm period. Climate change is nothing but basically a shift of pendulum between the coldest day or the coldest age on this planet to the warmest age on the planet. Of course, these are not the only reasons. You'll see that you have to combine it with the gases in the atmosphere, etc. But this is the basic of climate change. Why does climate change? So you'll see that tilt results in the Tropic of Cancer and Capricorn either coming together or going away from each other. So that is the impact of the tilt as such. Then we come to the next aspect, and that aspect is basically axial precision. Now, what does this axial precision mean? Now, you'll see that when we say the tilt of the axis is in two dimensions. Okay, from one angle to the other angle, from one angle to the other angle. Axial precision is something related to that, but you have to imagine that in three dimension. In the sense, if you have seen a top spinning, okay, I don't know how many of you all whether this generation plays with tops as such, but you'll see that when I did so when I was in my schools, okay, school, you'll see that when the top you release the top, you'll see that it starts spinning at a very fast speed. But when the speed goes down, you'll see that the top starts wobbling. Okay, now if you imagine the axis of the earth wobbling, that is nothing but precision. Wobbling of the earth's axis is precision. Tilt is in two dimension, wobbling is in three dimension. Okay, now what does this lead to? This leads to shift of those. Say for example, 24th, 22nd, 21st of June is supposed to be the summer solstice. In 7,000 years, what happens is the summer solstice will shift to September. Another 7,000 years, the summer solstice will shift of the northern hemisphere, will shift to December. And another 7,000 years, it will shift to March, and it will come back to this after 26 to 28,000 years. So this is how the cycle moves. Okay, and that is why you'll see that we are made to believe that of late, if you check that, if you speak elders in your house, they would say that, well, the monsoon used to arrive sharp in June, and that's say around 20, 27, 28, 29th of May in Kerala, and it would reach Pune by 7th of June. Nowadays, you'll see that it's going ahead, and it's going ahead, and at times there have been times wherein it arrives by 15th and 16th and 17th of June in Pune. This somewhere could be related to precision. We are not very sure, but this is what could be happening. Okay, so this is as far as the precision and the cycle of precision is concerned. Then let us move ahead, and this is orbital eccentricity. Now, what does this mean? Okay, you'll see that the speed at which the Earth is going around the sun is huge. Huge in the sense, now you see that we did see this in the next diagram as such. Here I have put here that the average distance between the sun and the earth is 150 million kilometers. Now if this is 150 million kilometers and this is the radius, you can imagine the circumference. The circumference is the distance traveled by the earth in so many uh, days. That's 365 days, right? Okay, you'll see that I have calculated it here. The if the formula for circumference is 2 pi r, okay, it comes to 942 million kilometers. Just imagine the planet Earth is traveling 942 million kilometers within 365 days. This is faster than the fastest of the vehicle available as far as the planet is concerned. Now, if the Earth is moving at that particular speed in around the sun, the gravitational force of the sun, if acting on the Earth, the gravitational force of the Earth partially acting on the sun, they tend to come into forcing into each other, which leads to a bit of change in the orbit. It's not a perfect circle. Presently, we know that this is elliptical. Okay, so you'll see that the orbit keeps on changing its shape from a circle to an ellipse, circle to an ellipse. Okay, so you'll see that while this happens, obviously the climate on the planet is going to be impacted as such. Okay, so you can see these happening in all these three, the three Milankovitch cycles. Okay, this is a very interesting thing to read, and in fact, all students of all sciences can go into the details of trying to understand what these are, because somewhere it has relation to everything that is happening around us, changing around us. So going into the details of Milankovitch cycles from the viewpoint of geography or any other subject, it's very very interesting. You can go to Google and you can search for this particular word, and you can read other details as far as Milankovitch cycles are concerned. So that is as far as the Milankovitch cycles are concerned. And then we come to the seasonal configuration of the Earth and the Sun. When we speak about the seasonal configuration, what all can we see and in this particular diagram in front of us? Okay, you'll see the Earth, which is exaggerated in size as far as the sun is concerned. That's the first thing you have to keep in mind. The second thing is that the Earth is going around the sun. Okay, it's going around the sun. Third thing is that the way in which the Earth is going around the sun is elliptical, and the next thing is that the axis at which the Earth rotates is a bit tilted. Now it is this tilt in the axis which creates these four positions which I was referring to. The winter solstice, where say the southern pole is seems to be, it does not shift itself, but the relative position of the axis, it gives you a feeling that that particular thing is happening. So you'll see that you feel that the southern pole is facing the sun, while on the opposite side, you'll see you have the summer solstice, wherein you feel that the summer northern pole is more towards the sun as such. And then you have these intermediate positions which are called as equinox. Equinox. Nox means light. Equi means equal. You have two types of equinox: the vernal equinox and the autumnal equinox. Okay, the autumnal equinox is when you move from summer to winter. That's in for the northern hemisphere. Let me tell you, these again are relative terms. Now, why have we named these terms with regards northern hemisphere? Basically, because a significant period of time, the say larger population on this planet has survived on the northern hemisphere. So most of the references are in context to the northern hemisphere and not in the southern hemisphere. That's a very important thing that we have to remember. You'll see that these positions, I could correlate them to the dates. Say, for example, when I'm speaking about summer solstice, this is going to be June. When I'm supposed to be speaking about autumn equinox, I'm referring to say September. And then I'm going to go into deep winter, that's December. I come out of winter in March, and then I go back to June. So this is how the Earth keeps going around this. Now we have to go into a few other details as such. I would want to go, but I would leave that for a later period, basically because second semester, all that we are going to do in climate is basically dependent on what you can see in front of you. In the sense, I will leave you with some questions. Okay, I'm partially answering that question, and within that, asking you a question. You'll see that if you have ever imagined, I don't know whether you did this, whether you asked questions to your geography teachers in your schools, that is there any similarity between the say the tilt in the axis of the Earth and second and that the Tropic of Cancer and Tropic of Capricorn are at particular latitude. Do you get the logic? You'll see that if the tilt in the axis of the Earth is 23 and a half, is the reason why you have the Tropic of Cancer at 23 and a half, and you have the Tropic of Capricorn and 23 and a half degrees south latitude. Now you'll get the reason why Milankovitch says that if the tilt increases, the tropics will go away from each other, and if the tilt decreases, the tropics will come nearer to each other, resulting into a warm age and an ice age respectively. Okay, so that is one thing that you have to remember. Then, have you ever thought as why do you have the Arctic and the Antarctic circles at 66 and a half degrees north and south respectively? Third question is, have you ever tried to add up these two, 66 and a half degrees and 23 and a half degrees? If you add both of them, what do you come to? What number do you come to? It is 90 degrees, isn't it? Okay, so try to understand the geography of this particular geometry. Try to understand the geography of this particular geometry. We will go into the details of that particular geometry when we are going to do climate, but I want you all to try and answer this within the comment section today if you know it, or we can discuss it on the on our chat box or WhatsApp app also. Okay, so that is as far as thing is concerned. Then we have some more time, and I will take up one more thing. Okay, you'll see that again there is something wrong in this particular diagram. Now, what exactly do you feel is wrong in this particular diagram? By that time, I will just tell you a few more things. Okay, if you remember, as far as the theme of geography is concerned, the theme of geography involves place, location. How do you locate a particular place on the surface of this particular planet? This is done by using a grid of lines, okay, which run horizontally, which run vertically. The horizontal ones are called as latitudes. The vertical ones are called as longitudes. Now, a very simple thing. If I cut the Earth from a particular vertical line and I open it up, what would it look like? It would look like an x-axis and a y-axis. Okay, so if you take points on the x-axis and you draw lines, vertical lines, these are going to be longitudes. If you take unit points on the y-axis and if you draw horizontal lines, you are going to call it as latitudes as such. So you'll see that the concept in science or sciences remain the same. It's only that you have to apply your mind. Okay, what is seen as a graph paper and an XY axis in sciences, and when you calculate temperature and other pressure relations in physics and chemistry, is seen as a locational grid as far as the Earth is concerned. You have latitudes and longitudes. Now, latitudes and longitudes are not a part of your syllabus, theory syllabus, but they are definitely a part of your practical one, and that is why I want you all to understand what this actually is all about. Okay, you'll see that characteristics of parallels of latitude. You'll see that this part here, I'll just see if I can have another diagram. Says no. Well, by this time, have you realized what is wrong as far as this particular diagram is concerned? You'll see that as far as this diagram is concerned, it should be like this. Means the axis is actually tilted at a particular angle. But then why are we presenting ourselves with something which is wrong? Actually, you'll see that for the matter of convenience, we are placing the Earth, say, straight. But actually, you'll see that because of the axis being tilted, the whole thing should actually, say, for some extent, it should be tilted at an angle of 23 and a half degrees. Now, what is a latitude? It is a point. It is a point on, say, it's or it's an imaginary line joining points, making a certain angle to the center of the Earth. So when I'm making the angle, say, making an angle to the center of the Earth, I need to have a horizontal. This horizontal is 0 degrees, and this is the equator. So you'll see that if I draw a line along the equator and I take any point on the surface of the Earth and I make these 2 points join at the center of the Earth, the angle that I get would eventually yield me 30 degrees, because if I take all the points in line next to that point, you'll see that I join these points, I would get a 30 degrees latitude. Similarly, I could go for 40 degrees. Similarly, I could go for 50 degrees. I could go all the way for 90 degrees. That's the pole. And it could be done either side of the equator. Towards the north, it's going to be called as the northern hemisphere and north latitudes. Towards the south, they are going to be called as southern hemisphere and south latitudes. You'll see that here 0, 20, 30, okay, 40, 50, 60. The mechanism remains the same. Okay, you just pull a line. Say, for example, now I'm showing you here from 60 degrees, I pull a line to the center, and this is of course the horizontal. If I measure this, this is going to be 60 degrees of latitude as such. So this is what latitudes are all about. It's all the points joining, okay, all the points joining to form an imaginary line which sustains a particular angle at the center of the earth to the horizontal, and the horizontal is the plane along the equator. You are slicing the earth along the equator, so that's your horizontal. And you go north of it, you go south of it, and you call it as north hemisphere and southern hemisphere as such. Okay, I don't want to confuse you further, but I'll just induce a few more thoughts about the latitudes here. You'll see that between 23 and now I suppose you have understood the significance of 23.5 degrees north and south, and the zone, the warm zone between them, it is called as the torrid zone. Just outside the torrid zone, you have the temperate zone, and all the way towards the pole, just around the poles, you're going to have frigid zones. So you'll see that climate wise, majorly you have three zones: the torrid zone, the temperate zone, and the frigid zone as such. Okay, so this is what happens when you'll see. Why does this happen? So why is the equator having warmer climate? The diagram to the left will explain this. You'll see that the beam of the sun rays is more or less direct near the equator, but you'll see that it tends to spread over larger areas as you move towards the poles. So the same light tends to be spread over larger area, and add to this the curvature of the earth. Both of these leads to the fact that the poles tend to be cooler as compared to the equatorial regions as such. Okay, details will follow later. Okay, now this is the diagram which discusses the differences between latitudes and longitudes. If you are to understand what is the difference basically between latitudes and longitudes, we have done latitudes right now, so we'll speak about latitudes, longitudes at some other time. You'll see that not all latitudes are equal in length. Okay, in fact, all latitudes are concentric circles. The equator is the longest of the latitudes, and the pole is basically just a point. It hardly has a linear extent. It is just a point. So these are concentric circles. These are full circles. Thirdly, they are parallel to each other. They can collapse into each other. In the sense, if I shrink them into, if I push the poles together, they will fall into each other, but they will still not cross. They will still not cross each other. Okay. And you'll see that the equator is also called as the largest of the great circles. Okay, these are complete circles. Okay, so these are major characteristics of latitudes. Now, as far as longitudes are concerned, we'll take up understanding longitudes at some other point of time, say next week. We'll stop here today. If you have any questions, as a matter of fact, I have some answers here. Harshal says that because sunlight does not fall on poles. Harshal, you'll have to be a bit more precise. What does it mean that because it does not fall on the poles as such? Then Ishwari says in the figure, vertical lines are called latitudes and horizontal lines are called longitudes, which is wrong. What was the figure? I'm not exactly sure. I'll check. Just a moment. Just a moment. I've now switched it off. I'll keep this in mind. Then that was an interesting observation. I'll just check into that. Harshal says latitude size decreases equator towards the poles. Yes, that's another good observation, that the length of the latitudes tend to increase from the poles towards the from the equator towards the poles. The longest of the latitude is the equator, and of course the smallest of the latitudes are at the poles as such. Okay, now this point made by Ishwari is still worrying me. If you give me some time, I'll just check into that also. You may not be able to see it, but I'm checking it on my laptop. This figure, the figure actually, it's a matter of understanding what they are showing in the figure. There's nothing wrong in this figure. Next time I will start with this very figure. Yes, this gives a feeling. This gives a feeling that longitudes are shown in a different way and latitudes are shown in a different way. But yes, I will go into the details of that when we meet next time as such. So that is one point that I have to keep in mind when we speak about it the next time. Then there is one more observation that has come up of late, and Shreya says that because of the 23.5 degree tilt, duration of the day and night are different all over the year. Otherwise, it would have been same. Yes, that's another excellent observation. Uh, that yes, it's only because of the 23.5 degrees that, if you remember, I was not much in discussion with you all, but as far as 29th of this is November, October, September, 29th of September, Pune, on the radar and weather app. Okay, the right corner you see the sunrise and the sunset times. 29th of September, if you check, it was 12 hours and 12 hours of night and 12 hours of day exactly. And if you check the say day and night today, it is a difference of 35 minutes. In the sense, nights are now longer by 35 minutes. Before 29th of September, you will see that the days were longer. Now the nights are getting longer. That's a very interesting observation. Then the sizes of all longitudes is same. Yes, the sizes are the same. But yes, as Ohm also says that the distance between the longitudes decrease from the equator to the poles. Yes, distance between two longitudes is maximum at the equator and it's minimum at the poles. In fact, they close into the pole. Okay, they all come together at the pole. Okay, so that's another interesting observation by you students. That was very good that you are responding to things happening during the lecture also. That's all for the day, and of course that's all for the week also. Tomorrow onwards you will have your lectures in human geography by Tigre sir. I will end my broadcast here.